Hello and welcome to the fourth lesson this week for maths. What we are doing now, as I had previously discussed with you in the previous videos, is we're going to do a little bit of revision. Now, we've learned quite a lot in this unit, and what I am going to do now is just work through some things which are going to come up again and again this year, and it'd be really good if we were very fluent in them before we move on. So some things, of course, in maths we will always readdress and we will build on. And when we're back in school, which hopefully will be very soon, we will be able to work through individual questions and things like that. But for the most part, there are a few things that as a year group, I just want us to work on. So the first thing that I want us all to work on and be super confident on is equivalent fractions, okay? Equivalent fractions means two different ways of representing the same thing, okay? So let's start by looking at this fraction, a half. There are millions and millions, there's an infinite number of ways that I can write a half as a fraction. I just need to make sure that the relationship between the numerator and the denominator stays the same. So, what is the relationship between the numerator and the denominator? Well, it is 2 times bigger. Okay, so what if I want to write this as an equivalent fraction? If I was asked the question, write a fraction which is equivalent to a half, then I need to write a fraction where the relationship is the same. So if I had 2 as my numerator, what would my denominator be? Well, I need to make sure that this relationship's the same, don't I? I need to multiply it by 2 to make sure it's 4. What's another? If I said this time, I want my denominator to be 6, what would the numerator have to be? Well done if you identified it. It would be 3. And so on. 4/8 and 5/10 and so on and so on and so on. Now, something that I say to you a lot related to equivalent fractions is whatever you do to the denominator, you must do to the numerator, or the other way around. So let's just check that I have done that. Okay, to get from here to here, what have I had to do? I've had to multiply by 2. Have I done the same here? Is 2 times 2 4? Yes, it is. Now, to get from 1 to 3, what have I had to do? I've had to multiply by 3. Have I done the same there? Is 2 multiplied by 3 6? Well, yes, it is. Moving on. What have I done to get from 1 to 4? Well, I've multiplied by 4. Have I done the same to my denominator? Yes. And last, to get from 1 to 5, what have I done? Well, I've multiplied by 5. Have I done the same here? Well, yes, I have. So when I get a question which says, write a fraction which is equivalent to, say, a quarter, all I have to do is do something, anything, doesn't matter what, to the top. Whatever I do, I must do the same to the bottom. Now, it's up to you how much you want to show off when you get a question like that. If you get a question like that, you might say, I'm going to keep it super simple. I'm going to firstly multiply it by 2. I'm going to multiply it by 3 or something. Or you might go, oh, I feel super fancy. So if someone asked me to write an equivalent fraction to a 6th, I'm going to times it by 17 to give me the answer 17. And I'm going to have to do 17 times 6, which is, quick bit of maths, Mr. Plummer, 102. And my answer is going to be 17 over 102. Feel free to check my maths was correct for that answer and write in a comment if I did make a mistake. Okay, the only other thing that we might get a question about equivalent fractions could be something along the lines of, it will ask you a true or false question. Are these two fractions equivalent? So let's have a look, for example, at 3/9 and 5/15. Now, how do I work out if these fractions are equivalent? Well, I have to look at the relationships between the numerator and the denominator. Okay, what do I have to do to get from 3 to 9? What have I done? Multiplied it by 3. So let's just check. Have I done the same there? Is 5 multiplied by 3 15? Yes, it is. So how about this one? So let me start that one again. Can you tell me whether this is correct? Is 2/7 equivalent to 4/16? Well, this time I have to work out, well, 2 to get to 7. What do I need to multiply that by? Well, I need to multiply by 3.5, 3.5. What do I need to do to get from 4 to 16? Well, I need to multiply by 4. I can see the relationships between the numerator and denominator are not the same. Therefore, those fractions are not equivalent fractions. That's equivalent fractions for you. The next thing is finding the lowest equivalent fraction. Now, when we did this in our lesson, a lot of us just didn't seem to quite understand the concept, and that's why we are going to readdress it now. When I'm finding the lowest equivalent fraction, I'm having to use my knowledge of factors and multiples. So, for example, let's say I have 6/18. If I was asked to write that as a lowest equivalent fraction, what I'm asking is for the numerator and denominator to get smaller, as small as they can possibly get, but still maintaining the same relationship. Okay, so the relationship there is that is 3 times bigger. So I need to make sure that the relationship on this side, when I have done it, is also the same, and I will use that to check my answer. Okay, what I need to do is work out what number I can divide both 6 and 18 by. So I could divide them both by 1. That's going to give me the answer 6/18 again. Not particularly useful. I haven't made it any smaller. So what else could I divide them by? I could divide them by 2. That's going to give me the answer 3/9. Now, I have made it smaller, but it's still not as small as it could go, because 3/9, 3 and 9 can both be divided by 3 to give me 1/3. So that's what I'm doing. I'm either looking to get to a point where one of either my numerator or denominator is the number 1, in which case I can stop, or there are no further numbers that I can continue to divide by. So let's have another look at this one. Let's have a look at 8/64. So there are lots and lots of things I can do to these numbers. I could divide them both by 1, but that's not really going to help. I could divide them both by 2, which would give me 4/32. Now I can divide those again by 2 and again and again and again. So what you need to do is use your knowledge here of times tables. Now, I can know that both 8 and 64 appear in which times table? Well, of course, the answer is the 8 times table. So I know I can divide both of these numbers by 8. 8 divided by 8 is 1. And 64 divided by 8 is 8. So the 8/64 is equivalent to 1/8. So these types of questions are really simple because the denominator is in the times tables of the numerator, and that makes it really straightforward to us. But what happens when it isn't? Let's say we had 10/25. Okay, now 25 does not divide evenly by 10. It would give me a decimal number or a fraction, which I don't want. So I need to identify a number which both 10 and 25 can be divided by. Now, they can both be divided by 1, but that isn't going to help me. Can they both be divided by 2? No, they can't. Can they both be divided by 3? No, not evenly. 4? No. But 5? Oh, yes, they can. 10 divided by 5 is 2, and 25 divided by 5 is 5. Now I've got these two numbers. Can both of these numbers be divided by something other than 1? No, they can't. 2 can only be divided by 1 and 2, and 5 can't be divided by 2 because it's an odd number. So that is the lowest equivalent fraction to 10/25ths. Another one I might get is something like this. So again, I'm going to have to work out what I can divide these by. So I might have to go through, well, 1 is not going to help me out because it will stay the same. Can I divide it by 2? No. Can I divide them both by 3? Well, I'm 21 by 3. I can't evenly divide 49 by 3. So I'm going to have to move on. Can I divide them both by 4? No. Can I divide them both by 5? No. 6? No. 7. 7 is the number that is a factor of both 21 and 49. So I need to divide by 7. 21 divided by 7 is 3. And 49 divided by 7 is 7. And every single time I'm dealing with equivalent fractions, whatever I do to the top, I must do to the bottom. Whatever I do to the bottom, I must do to the top. And remember, I said you can check the relationships between the numbers sometimes as well to help you out. Now, the last thing I might get with equivalent fractions, the only other thing I have to be wary of is something like this. If I get 50 over 100, I go, bosh, easy. I can see both of them 10 times tables. Absolutely love it. So I'm going to say that is equivalent to 5/10. Now I'll wipe my hands and I'm going to move on to the next question. Can you identify the mistake that I've actually made there? Well done if you were able to work out that, yes, these two fractions are equivalent to each other, but I can make it even lower because 5 and 10 can both be divided again. They can both be divided by 5 to give me the answer, a half. And I'm just going to check the relationship between my numerator and denominator. What is the relationship between 50 and 100? Well, it's twice as big. What's the relationship between 5 and 10? It's twice as big. Good stuff. Equivalent so far. What's the relationship between 1 and 2? Twice as big. So this is just something that I need to be wary of. Always check your answer. Can't then be divided again. And remember, I'm looking for the lowest equivalent fraction. The last thing, and I've mentioned this a few times this week, and I did last week as well, and I'm going to mention it again now, are common fraction decimal equivalents. I just want you now to have a quick think to yourself about these fractions and what they are written as decimal numbers, okay? 1 over 1. A half. A quarter. 3/4, a tenth, a 100th, a 1,000th. I want you to just pause the video, and if you're working with someone, have a talk with them, and if not, just try and work them out on your own. These are ones that we now need to start to be putting into our long-term memory. So pause the video now, please. Welcome back. If you are able to identify the following. 1 over 1 is equivalent to 1. Anytime the numerator and denominator are the same, it is equal to 1. 2 halves, 3/3, 4/4, 5/5, 6/6 is always equal to 1. A half is 0.5, 5/10. A quarter, 0.25. 3/4, 0.75. A tenth, 0.1. A hundredth, 0.01. And a thousandth, 0.001. If you learn nothing else from this unit, which I know doesn't apply to anyone, but if all you could do from this unit was memorize these, you would still have achieved a lot. Now, obviously, we don't just want to memorize things just for the sake of it, but remembering these fraction decimal equivalents is really going to help us with all sorts of things in life, including fractions, decimals, percentages, distances, measurements, times. We often see things like 0.5 and a half, 50%, things like that, all being used interchangeably. Some people might say one and the other. And the more we can get used to these being equivalent in our head, the easier it will be moving forward with fractions and decimals. Please now have a look at your independent task. Challenge 1, I have asked you to tell me whether the two fractions are equivalent to each other and then explain why. And you can go back to that first little bit of this video to see how I check whether fractions are equivalent to each other. This time, I'm finding that lowest fraction. So again, you can go back to that bit of the video, the middle block of this video, and have a look at how to work those out. Remember, it must be not just lower, but the lowest. For example, if you had, have a look at that 51/100th example that I gave you earlier in the video. Last but not least, you need to fill in the blanks. So in some occasions, I've given you the fraction, and I want you to tell me the equivalent decimal. And in another case, I've given you a decimal, and I want you to give me the equivalent fraction. Now, all of those I have told you already. Please try and commit those to your long-term memory. Okay? 3 challenges, 3 tasks. Over to you.